far no guesses to which planet. Come on.
Saturn.
Yes, that's right. Come on, who else wants to go?
Is that one there? What do you reckon on that?
I can see a ring with a blob in the middle. It's a blob.
It's a blob. You're all into blobs, you lot, aren't you?
and it's got a ring around it.
Uh-huh.
And it looks green to me.
Today, we can do much better than just stand and stare. OK, the view through a telescope's all right, but it's continually blurred by the shifting of our atmosphere. Nowadays, we, or rather our instruments, can actually go there by space probe. Already, 4 probes have visited the planets of gas. There were tantalizing discoveries. Rings around Saturn which, apparently, defied the laws of nature. Gigantic storms on Jupiter many times bigger than the Earth. And, most unexpected of all, a whole system of encircling new worlds. Worlds of ice and worlds of fire. At the heart of our solar system are 4 small solid planets. Jupiter and Saturn are the first of the outer planets, worlds quite unlike our own. To us, the Earth seems vast, but compared to Jupiter, in fact, Jupiter's bigger than all the other planets put together. Saturn is only slightly smaller, but its rings would nearly bridge the gap between the Earth and the Moon. Both these huge planets have been easy targets for telescopes since the days of Galileo, and it's astonishing how much astronomers were able to find out. Galileo himself found that Jupiter wasn't alone. It's circled by 4 moons, big enough to be planets in their own right. Here was proof that not everything circled the Earth. And incredibly, only decades later, Ole Romer timed these scurrying specks and came up with the first accurate estimate of the speed of light. Over the years, astronomers discovered Jupiter was a very different world from the planets close to the Sun. They were even able to work out what lay beneath its swirling clouds. They deduced that most of Jupiter is an enormous globe of hydrogen and helium gas. Deeper still, under huge pressure, the gas becomes a silver sea of liquid metal. And right at Jupiter's heart, there's a super-crushed rocky core, glowing red-hot in the darkness. In short, Jupiter is a giant gas bag. Distant Saturn is a smaller version of Jupiter, but not quite so dense and compressed. In fact, it could float on water, given an ocean large enough. March 1972, the start of the longest journey ever made as the first of 2 Pioneer probes heads off towards Jupiter and Saturn. It's a voyage into the unknown. But the launch rocket isn't powerful enough to send Pioneer all the way to Saturn, and so the flight involves an untried maneuver in interplanetary ballistics. Using Jupiter's gravity to speed it up, Pioneer would be looped around the giant planet and flipped back across the solar system in a 4.5-year journey to rendezvous with Saturn. It was to be the cosmic equivalent of scoring a hole-in-one from 50 miles. And even as the Pioneers are hurtling across the solar system, space scientists are busy constructing the next generation of explorers, purpose-built to investigate the outer planets. These were the Voyager probes. December 1973, cameras rolling, Pioneer 10 becomes the first spacecraft to approach Jupiter. As it closes in at 40,000 miles an hour, it encounters a mysterious zone of intense radiation. With the Voyager craft close to completion, scientists had to do some quick thinking, as Brad Smith recalls.
That was the unexpected. That was this extremely intense radiation belt around Jupiter. So intense that, in fact, it would have destroyed the Voyager spacecraft. After Pioneer told us about it and told us how severe it was, we were able to make some design changes in the spacecraft and the instruments so that we survived quite well.
Pioneer lived to tell the tale. In its quick loop of Jupiter, it sent back our first glimpses of the planet's swirling clouds.
Well, they told us that the atmosphere of Jupiter was rather more complex than we had deduced from our ground-based observations. And so we were somewhat prepared for it, but Voyager showed an even more complex system than Pioneer had hinted at.
The Voyager craft had been saved from an ignominious end by the trailblazing Pioneer probes. And these new craft were built to go much further and give far more information than their predecessors. The two Voyager probes could actually think for themselves without always having to rely on a command from Earth. On board, they had 3 computers make up a kind of robot brain, as well as TV cameras and dozens of other instruments. And the pictures they sent back from Jupiter were absolutely incredible, the best to date. 2 years and 400 million miles later, Voyager 1 draws close to the king of the planets. In the last few days of its approach to Jupiter, its cameras produced a time-lapse record of the turbulent planet through a cloud-enhancing blue filter. Most stunning of all, Jupiter's great red spot, a mysterious oval first seen 300 years ago. Voyager reveals it as a huge weather system, 3 times bigger than the Earth. Years and 400 million miles later on its epic journey, Voyager recorded the spinning rings of Saturn. And with computer enhancement, the pictures show tongues of swirling cloud whipped along by the fastest winds in the solar system. Saturn, too, has its own red spot. Voyager's pictures are helping towards our understanding of the solar system.
These large planets are still contracting from their birth 4.5 billion years ago. That contraction is still going on, very, very slowly. And that compression of the planet releases heat from the interior, which works its way out.
And is the same true of Jupiter?
Yes, in fact, in the case of Jupiter, all of the heat that's coming from the interior is due to that contraction. Saturn is a little different. It's some separation of the helium and hydrogen that produces an additional amount of heat.
And presumably on both Jupiter and Saturn, it's this heat that drives around the atmosphere.
Yes, that's the mechanism that drives these enormous weather systems that we see on both of these planets.
So the ultimate cause of Jupiter and Saturn's turbulent atmospheres dates back to their birth 4.5 billion years ago. Planets were formed in the gravitational collapse of a great cloud of swirling gas and dust. The gravitational energy of this gas and dust falling inwards heated the planets as they formed. Jupiter and Saturn have not yet cooled off. They give off far more energy than they receive from the Sun, and it's the heat from their compressed cores that powers their violent storm patterns. there was more. As Voyager flew round Jupiter, it made a startling discovery. Its cameras turned back and revealed a faint, thin ring of countless tiny rock splinters. But Jupiter's ring is the palest shadow of Saturn's glittering tiara. Earthbound astronomers could only see 3 rings, but Voyager revealed literally millions. Voyager couldn't fly through the rings, but it had an instrument on board to measure how wide and how thick they were. As the rings passed in front of the distant star Delta Scorpii, its light intensity flickered, and scientists got their chance to make measurements of the ring system.
We now know that they're only perhaps tens of feet thick in places and hundreds of thousands of miles across. If you were to make a model of the rings, the thickness of a sheet of paper, for instance, you'd have to get a piece of paper about, a half a mile in diameter in order to make that. So you get a very, very flimsy, very, very thin ring system around Saturn.
The rings are so thin, you can actually see through them. So what could they be made of?
Well, we think they are made of water ice, but because their colors are slightly different than the color of just plain water ice, we know that there's some contaminating material mixed in with the ring particles. The particles probably range in size anywhere from dust-sized particles to the size of a house.
Saturn's ring system was full of surprises. When Pioneer 11 had shot past the planet, it sent back a blurred picture of a new, thin, mysterious ring at the outside edge of the system. Voyager's more detailed photographs showed that this ring appeared to defy all known laws of science. In close-up, it appeared to have kinks and twists. But now we know why.
It's called a shepherded ring. That is, there's a satellite just on the inside and just on the outside of this ring. And those 2 satellites tend to confine the material in a very thin, narrow ringlet. In fact, the motions of these satellites, because they don't orbit Saturn exactly in circular orbits, tend to tug on the ring particles and actually create very strange and exotic shapes, much like a braided pattern.
It sounds rather like dogs herding sheep and making sure they stick to the middle of the road.
Exactly, and it's one of the mechanisms that was uncovered to understand some of the ring structure.
So perhaps there could be other small satellites splitting the system into millions of rings, making Saturn the grooviest planet in the solar system. The trip past Jupiter and Saturn was the first opportunity to examine, in close-up, moons visible from Earth only as tiny specks. Voyager reveals strange new worlds, and at Saturn, far more than had ever been expected.
Before Voyager, the number of moons was something in the order of 10 or 11. There was a little bit of controversy there as to whether there were 1 or 2 in a particular orbit. And Voyager has now brought that number firmly up to 17. That is, we know exactly where they are at all times. Their orbits are very well determined.
And that's a record, isn't it, for any planet?
That's certainly the largest number of any planet, of the satellite moons that have yet been discovered.
So Saturn can boast the largest family of moons in the solar system. Most of Saturn's moons are just airless balls of ice, battered and scarred with craters. But there was one astronomers really wanted to see, the giant moon Titan. They thought it had an atmosphere, the only moon in the solar system to have one, and hoped to see close-up views of its surface. Titan does have an atmosphere. Thick orange clouds cloak its surface, clouds so thick cameras couldn't penetrate them, and its secrets remain hidden. When Voyager swept past Jupiter, it took family portraits of its 4 biggest moons, the moons first seen by Galileo. Turning its cameras on Ganymede, a moon bigger than the planet Mercury, Voyager showed us a world festooned with ribbons, mysterious groups of parallel grooves and ridges trailing over the moon's surface. Jupiter's crater-scarred moon Callisto sports an enormous bullseye, the legacy of a direct hit by a huge meteorite. Flying past Europa, Voyager discovered it was made almost completely of ice and smoother than a billiard ball. Its surface is crisscrossed with narrow cracks. Some scientists speculate there could be liquid under the ice, harboring primitive life forms. But if the findings on the other moons had been a surprise, then hot-blooded Io came as a shock. The first pictures of Io revealed what the Voyager team thought was a cloud. But to everyone's amazement, it turned out to be a huge volcanic eruption. Lakes of molten and solidifying lava spot its surface. Its appearance is changing almost daily as new eruptions spray fire and brimstone into space. Io is the only world, apart from our own, on which volcanic eruptions have actually been seen. Io's volcanoes spew clouds of gas, much like Earth's geysers spray plumes of steam. Sue Kiefer is a geologist who's been studying volcanoes both on Io and on the Earth.
Sunset Crater and most of the volcanoes on Earth are made of a melted rock that we call magma. The volcanoes on Io are made of sulfur and sulfur dioxide.
And when they erupt, how high does the eruption go?
Some of the tallest eruptions go 250 or 300 miles.
Incredibly high. How does that compare with Earth?
Well, most of us have seen Old Faithful Geyser in Yellowstone. On Earth, Old Faithful erupts to about 100 feet in height. If Old Faithful were on Io, which has a lower gravity and a negligible atmosphere, it might erupt to almost 25 miles.
That's incredible.
Well, it might have been discovered as a small volcano by the Voyager spacecraft.
Once Voyager had found the volcanoes, astronomers turned their telescopes on Io. They discovered the eruptions leave behind a trail of gas which could be photographed from Earth. These gases spread out to form an invisible ring around Jupiter, displayed here in computer graphics. And other things lurk in the apparently empty space around the giant planet. Mighty electric currents circle endlessly under the influence of Jupiter's powerful magnetic field. This magnetism is generated deep in Jupiter's heart and extends millions of miles into space. Following the tilted magnetic axis of Jupiter, the huge magnetic cage swings and sways in the ocean of space. The space probes gave us our first close-up look at these outer worlds, worlds we thought we already knew. But there was far more to see and learn than we could ever have guessed. The swirling clouds of Jupiter and the mighty rings of Saturn harbored unexpected secrets. More than anything, it was the moons of both planets, in their number and variety, which really intrigued the scientists. It had been like discovering two new solar systems in miniature. When space shuttle flights start up again, after the long grounding which followed the tragic loss of Challenger and her crew, we'll be going back. A giant catapult on board the shuttle will launch the probe Galileo on what will be our next visit to Jupiter and its moons. While it was still under construction in a room pumped free of all dust, I was given a guided tour of the spacecraft by Torrance Johnson, the chief project scientist.
The bulbous bit sticking out.
Yes, large tanks for the propulsion system. That provides both the attitude propulsion.
Although carrying far more instruments than its predecessor, Voyager, Galileo somehow had to be built to fit in the shuttle.
Well, this is the main communication dish for the entire spacecraft. And it, of course, has to be very light and flexible so that it can fold up inside the space shuttle.
The stuff it's made out of looks just like sort of stocking material, doesn't it?
In fact, it was woven on the same type of machine that is used to weave pantyhose.
Galileo is 2 spacecraft in 1. As it nears Jupiter, it will release a small probe to investigate the depths of the planet's turbulent atmosphere.
Here we got the probe.
It's amazing. It's quite compact, isn't it?
Yeah, and as you can imagine, this thing hitting the atmosphere of Jupiter at a little over 100,000 miles an hour.
Oh, I'd rather not.
It descends on a parachute, going approximately 100 miles into the atmosphere of Jupiter, radioing data back to the orbiter flying overhead. And then eventually, after we've stopped listening to it, the pressure and temperature of the Jupiter atmosphere will get to it, and it will be crushed, vaporized, and actually become part of Jupiter itself.
What an end.
Meanwhile, the main craft will become a man-made moon of Jupiter, probing the intense radiation belts and returning for another look at those tantalizing moons, first observed by Galileo himself almost 4 centuries ago.
Radioprogramma 5 is volgende week dinsdag om 9 uur via Radio 5. En wat u daarin kunt verwachten, laten we u nu vast zien.
Wij zullen misschien opstijgen van deze saaie aarde en haar van boven kunnen zien. Zo zullen wij als reizigers naar andere verre landen beter in staat zijn te beoordelen wat er thuis gebeurt. We zullen minder geneigd zijn te bewonderen wat deze wereld groot noemt, wanneer we weten dat er een veelheid bestaat van zulke werelden, bewoond en getooid gelijk de onze. Aldus Christian Huygens zo'n 300 jaar geleden. Inderdaad, andere werelden, alhoewel ze niet bewoond en getooid zijn gelijk de onze. Verschillende werelden, zoals hier de maan Europa bij Jupiter. Glad als een ijsbal en tegelijk gegroefd met donkere valleien. Of neem Io, de meest merkwaardige maan van het zonnestelsel. Geen kraters, maar een felrode en gele substantie op het oppervlak. Toen we Io voor het eerst zagen, wisten we er geen raad mee. Ganymedes, de grootste maan van het zonnestelsel. Het oppervlak vertoont allerlei tekenen van inwendige activiteit. Er kunnen vulkanen zijn geweest en bodemschokken, maar er zijn ook talrijke inslagkraters te zien. Callisto, de laatste van de 4 grote manen die door Galileo zijn ontdekt. Een oud terrein vol met kraters. Bijna uit elkaar gespat na de inslag van een groot hemellichaam. Nog even terug naar Io. Misschien wel de meest onverwachte ontdekking van de Voyager-missie betrof deze opname. een uitstulping aan de rand van Io. In werkelijkheid een actieve vulkaan waarmee zwavel uit het binnenste over het oppervlak wordt gestrooid. Plotseling begrepen we veel meer van de andere foto's. Geen kraters, omdat die spoedig worden uitgewist. Jupiter, de reus in het zonnestelsel, met een machtige, dikke atmosfeer waarin de gekleurde wolken steeds wisselende patronen laten zien. Soms wordt er gespeculeerd dat Jupiter een mislukte ster is. Hoe het ook zij, er zijn volop raadsels, zoals de oorzaak van deze grote rode vlek die al eeuwen bestaat. We gaan terug naar Jupiter. Nog dit jaar moet de Galileo-missie via een space shuttle in de ruimte worden gebracht. Naast gedetailleerd onderzoek van de manen zal er ook een landing in Jupiter worden gemaakt. Een zelfmoordmissie om diep door te dringen in de geheimen van Jupiters atmosfeer. Vragen te over. Gelukkig ook enkele antwoorden. Teleac, Radio 5.